tomorrow's version of the test, I believe I made 20 points. And then Monday's is worth 20 points. But it might be 40 and 40. I can't remember. Can't remember if there was going to have to be 40 or each one was 40. I'm sorry. All right. Yeah, you should have seen this class yesterday. I had this desk where Mikey's at, that table by Gabby, and I had all the rows straight that way because to proctor correctly, everyone had to face the clock. So,
Wow. That's great.
but so I don't know. Just to rearrange a little bit. If I had an outlet in the middle of the floor, I would probably have this desk in the middle right there. But I don't know. Of course, during proctoring, this guy is as bored can be. Oh.
You should get one that goes all the way around, so you can just
Like swivel desk, like an on.
And it just rotates at a certain.
Yeah, exactly.
Goes
Or
clockwise.
Just a giant circle. You sit in the middle and you just look at everything.
Just on a swivel chair.
Yeah.
Love it. It's coming. It's coming. Actually, what I'd like to do is, eventually they're going to get these holographs down. So I'll have like my phone camera facing me, and then a holograph of me will be like in the middle of the classroom.
2 feet taller and 10 years younger.
Lots of hair.
Yeah.
It'd be awesome. All right. Hey, friends, so page 123, please. You have it out?
Yes.
All right. So this says a blood test of a certain disease has an accuracy of 97%, but a modification to this test were developed with a goal to have the test to be more than 98% accurate. To test, 60 random people are chosen to participate, and 59 of them produced an accurate test, which was 98.33. Okay. So item 1. Would you think that drug companies are getting tests, refining it more and more and more to become better and better? I would think so. I mean, the process of early diagnosis can be a lot better than something that's like, yeah, we're like 30% certain. All right. Let's break this down right on that. All right. So it says, so on page 123, problem number 1. Friends, do you think it's, it says, which hypothesis is appropriate here? Well, this would be a 1 proportional z-test. And I will tell you why. So it's one tail because they had showing greater. You have a random sample. And then what else do we have here? Oh, and then we have percents. So that's basically going to be a good target for your one proportional z-test. Okay, this is already answered this above. Is this 1 or 2 tail? It's 1 tail because they're trying to show more than. Okay, or if they said more than or less than, it's going to be 1 tail. If they said we wanted to show that we had a difference in our test, then it's 2 tail. All right, they want us to state the null and the alternative. All right, so I'm going to come over here and I'm going to say mu. Mu is test result. So then I could say, well, is mu equal to the 97%, the original, or is mu greater than 97%? Okay, and there's all the information we need so far. We're on page 123, my friends. 123 when you get it. 123? Has anyone else's eyes started itching because things are starting to bloom? Because mine are.
No.
Yes.
My dad was really funny. His entire face.
All right. So then problem number 4, we want to find the standard error. So being that there's percents given, your standard error is going to be the probability, 1 minus the probability divided by the sample size. So in here we're going to say that, well, this is going to be 0.97, and then 1 minus 0.97, which is 0.03, and then we'll divide that by 60, and this comes out to approximately 0.02. So this is my standard error. And remember, standard error goes in place of the standard deviation because we have a random sample. It's not, so that's why we're not going with the entire standard deviation. All right, are we good so far with that? Almost okay. Taking time. While you guys are finishing that, I will tell you that your test will have, the front page will be, I think, 5 multiple choice. Backside of that page would be a problem similar to this. And then the third page, or the front of the second page, on page 123, will be 5 more multiple choice, and then the backside will be another type of problem, like something like this. And then that'll be the same type of thing for Monday. Cool? All right. Did anyone still need that? You good? So number 5, we want to draw ourselves a normal distribution. Hey, friends. We're on page 123. All right, so this, I'm going to keep them as percents. So this is 97%. Hey, I have a question for you. 97 is 0.97, agree? 0.02 is what as a percent? 0.02 is what as a percent? 2%. All right, so being I'm doing percents, I'm going to just do that this way. So this goes to 99%, and then it gets into the goofy category, because this is 101%, this is 103%. How are you going to have a test that's 103% accurate? It can't be done. So, like, theoretically, there's a part of this normal curve that doesn't make sense, but we're just writing what we have. 95%, 93%, and 91%. So these are definitely things that I'm looking at on the test. And then they tell us that that their sample came up with a 98.33%. Okay, and remember we want it to show greater, so 98.33. So we're talking about like this is the region we're looking for. That's what we have to find the p-value on this eventually. So this mark here would have been at 98.33. And those are all things that on the test, like, did you shade a region? Friends, if you shade an entire normal distribution curve, you're going to miss a point on that. Okay? Some of you will shade all the way under the curve, and I get it. It's pretty satisfying to shade the entire region underneath. I get it. But we only want a portion of it shaded. All right. Now it's looking for the p-value. What do we do to get the p-value? Desmos, absolutely. Okay, and this is going to go under a normal distribution. And I think the backside of this paper is actually not going to have a normal distribution. It's going to be a t-distribution, and I'll show you why. This is a normal distribution for a lot of reasons. Normal distribution because we have 60 random people. We have Because we have 97% as a whole. We have a random sample of 60, so we don't have to worry about a t-distribution in this case. And so let's go with that. Let's jump on Desmos. Let's see what we did. We're on page 103. All right, let's see what the Desmos family is up to. What do you mean? There we go. Computer's thinking. Hey, Bob. We're on page 103. Or 123. Normal distribution. So we have a mean. We can keep it. We can either make it 0.97 or 97%. So I'll keep it as 97%. So that means my standard error isn't going to be 0.02. It's going to be the 2%. So this is what our normal distribution is going to look like in this case. Darken it up a little bit. And then I want to find p-value, and we're going to the right, so I'm going to put in for negative infinity. We had this 98.33. Okay, so p-value up here, 0.25. Pretty high p-value, yes? Does that make sense how I found that? Okay, so we have a p-value of equals 0.25. They didn't give us an alpha or a p-value to look at, so then we want to know is our general rule of thumb, is our p-value less than 0.05? Well, 0.25 is greater than 0.05. So what do we do in this case? Do we reject or do we fail to reject? Reject is when that p-value is tiny. Okay? Okay? So let's put a little note so it doesn't, you don't miss it on the test. Good? This is much larger than the p default value. Okay, 0.05. So that means we are going to fail to reject the null. That means we found evidence. We did not find evidence that would. We didn't find evidence against the null. We might have found a real slim part of evidence, but it's not enough evidence to say, oh, look. So this is basically problem number 7. Oh, shoot, I looked right at it. They gave us, I apologize, I didn't even look at it. They gave us an alpha of 0.05, so this still checks out with what we have there. Okay, so we're given alpha. Okay, are the assumptions passed? Okay, well, we had random. They told us it was random. We had 60, which is larger than 30. Okay, so this seems to pass. This seems like it was a relatively legitimate stat analysis, so I like it. Okay, friends, if you saw a problem similar to that, you think you could do it? Could you answer the questions about it? Okay. May I move on to the next problem, which is on page 124. You guys are writing that. I'll do some attendance. All right. So page 124, you ready? All right, page 124. All right. It says a taste test is developed for a new food products by a popular restaurant chain. New food products need a rating higher than 7.0 on a scale from 1 to 10 on taste tests in order to be considered for an addition to the menu. A brand new product has been tested by 100 people and produced an average score of 7.8 with a standard deviation of 1.2. Is this significant evidence that this product has passed and should be considered for an addition to the menu? All right, so friends, they had a sample of 100. It's a really good number. But what am I missing here? What's a red flag that sticks up because of our rating? Yeah, random, not stated. Okay? And again, friends, these are things that you need to keep in your mind. It doesn't mean we can't go through and do the math, but because they said, hey, we had 100 people, that is not a random sample. Okay? It didn't say it was a random sample of 100 people unless I misread something. It says a brand new product has been taste tested by 100 people. We don't know anything. Okay? So they want our mean to be 7. In our sample, in our X-bar sample, was 7.8, and the sample standard deviation was 1.2. Okay. So a couple things that stick out to me. We don't have a random sample. We do not have a standard deviation of the entire population. Okay, we have the business said, hey, we want our score to be 7 before we even consider adding a new menu item. Shame on that company for only selecting 100 people, not randomly, just saying, hey, come do this taste test. It's not random. Okay? So this is going to be a t-test. It's a t-test because our standard deviation is from the sample. Okay? So that's kind of important. Is this a 1 or 2 tail test? It's 1 tail because we want higher than 7.0. Okay? And then state the null and the alternative. So we're going to use mu, and we're going to say new item. New item taste or something like that. So this is going to be mu is equal to 7.0 and mu is greater than 7.0 because they want their target to be 7.0 or higher than 7.0. Okay? Then they ask us to find the mean and the standard error. Well, the mean is 7.0. Okay? And then the standard error is going to be 1.2. All right, I'm sorry. I'll give you the equation. Sample standard deviation divided by the square root of the sample. So this is going to be 1.2 divided by the square root of 100. And if we did this math, it's going to come out to roughly 0.1. So that's our standard error. Okay? If you did it, it comes out to 0.12, but I just rounded to 1 decimal because we don't need to be that accurate. All right. All right, now I'm going to put a note here. This is a t-test. A t-test is using degrees of freedom. So now I want to find the z-score. And the z-score is the observed minus the mean over the standard deviation. So my z-score in this case is going to be 7.2 minus 7.0 over standard deviation of, we had it right there. Where's it? Where'd it go? Where'd it go? Where'd it go? 1.2. Thank you. So this is going to give me a z-score of 0.17, which is close to what our standard error is, but it's off just enough that we want to make sure we use the z-score. Okay, so again, the z-score, remember the z-score is how far away are you from the standard deviation, okay, or from the mean. A t-score or t-sample distribution is going to look like a normal distribution, but it's based on degrees of freedom, and so it's bound from 0, 1, 2, 3 to negative 1, 2, 3. So that's why we have to use that type of z-score. All right. Look at that. I gave you room right to slide right in. Perfect. All right. So we have this. And we're just going to draw this. Okay, so this is what our sampling distribution looks like. This is going to look similar to our t-test sample distribution, but our t-test, so our t distribution will actually have things labeled like this. Okay, so that's basically where our difference is taking place on this. Okay, it looks the same, except I'm going to change my markers, and being that I have a z-score of 0.17, I'm going to use that. All right, so now we have to find our p-value. So our p-value is going to be everybody's friend, the Desmos family. I don't know if they're really a family, but I refer to them as that. I feel like Desmos is more reliable than most families, so. All All right. So I'm going to go T distribution. T distribution says degrees of freedom. If I have 100 people, what is my degrees of freedom? 99. Okay. There's our normal distribution. Find the probability. So we're going to go 0.17. 0.17 is to the right of 0. So I want 0.17 or higher. So we are at 0.43 for a p-value. So 0.43. All right, number 7, they want us to do an alpha of 0.05. Okay, alpha of 0.05. Well, 0.43 is greater than 0.05. So in this case, we are going to fail to reject the null. Okay. And then we didn't find strong enough evidence to reject the null, so we're going to fail to reject it. And the big red flag here is it's not random. So that, my friends, between this review page and the one before, I'll actually let you use, why don't you just use all of your notes for this chapter on the test tomorrow. So again, the test is Friday for part 1 and Monday for part 2. They're equivalent in size. They're both worth the same amount of points, but I just want you to do the best you can on it. I think you can. So we'll go from there. Sound like a plan?